Okay, so today I wanted to start talking about solving systems of equations. And the first thing we have to talk about is what is a system of equations. Okay, and let's just take a look at one equation to start with here. Okay, so let's take a look at something like y is equal to 3x minus 7. Okay, now the equation y equals 3x minus 7 has some solutions. Okay, like so when we say what is x and what is y, there are pairs of numbers that can match up. Okay, and what we do is when we look at a pair of numbers that do match up, say for instance 1 and negative 4, okay, we'll see what happens when we plug these in. Okay, we say y is negative 4 is equal to 3 times 1, so we substitute these in, minus 7. You got negative 4 is equal to 3 minus 7, and negative 4 is equal to negative 4. Okay, and that gives us a check mark. Okay, so yes. Okay, and so what we can say is that the point 1, negative 4 satisfies the equation. Satisfies the equation. Okay. Now what this really means is that the point 1, negative 4 is a point on the line described by y is equal to 3x minus 7. Alright. Now the problem though is that it's impossible for us to say exactly what, well, a specific value of x and y, because there is actually an infinite number of them based on this line. Okay. So if I were to draw this line, okay, what I would get is a y-intercept of negative 7, so that would be 1, 2, 3, 4, 5, 6, 7. Okay, and I'll draw this actually in just a different color, so let's go purple. Okay, so I draw a little point there. The slope is 3, which means it goes 3 up for every 1 across it goes, so 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. Okay, so something like that. And I can draw a line passing through all these points. Okay, and that line there would be the line of y is equal to 3x minus 7. Okay. Now, the reason why this has an infinite number of solutions, though, is because any point on this line can satisfy the equation. Okay, so for instance, like here we had a point as x is equal to 2 and y is equal to negative 1, and x is equal to 1 and negative 4, or x is equal to 0 and negative 7. Any of these lines, and all the ones in between, even the rational and irrational ones, can solve the problem. Okay, so there's no unique solution. Okay. Now, when we have a system of equations, what we mean is that we have more than one equation. And when we have a system of equations, what we can do is we can find a unique solution, especially when you have a system of linear equations. Okay, so let's say, for instance, I added another one here, and I said y is equal to x plus 1. Okay, now all of a sudden, what I've done is I've constrained this equation with another equation, and now what we're trying to do is find a solution that satisfies both equations at the same time. With this, once we've introduced this, what it means is that we can find a unique solution. And I'll show you how we can do this graphically. Okay, so y equals x plus 1 has an intercept of 1. Okay, so y-intercept is 1, and the slope is 1, so it means it goes up 1 and over 1 every time for every increment here. Okay, so it looks like that. Okay, and so if I were to draw this, okay, like that, I'm not going to draw it over the equation, but technically it goes into infinity. Okay, what we would see is that these two lines, sorry, the purple line and the blue line, okay, they meet at a point. Okay, and I will circle this point in green over here. Okay, so they meet right there. Okay, now that point represents the solution to the system of equations. Okay, and let's just find out what that point is. Okay, so if I take a look at it here, I have 1, 2, 3, 4, 1, 2, 3, 4, 5. So the point is 4, 5. Okay, now what we can do is we can check and see if these satisfy this equation. Okay, by substituting these values in for x and y on both equations and seeing if it works. Okay, so what I do is for this one I have 5 is equal to 3 times 4 minus 7. Now 3 times 4 is 12, minus 7 is 5. So 5 equals 5. This is true. Okay, for this one I have 5 is equal to 4 plus 1. Okay, that is also true. Okay, so this point 4, 5 is the only one as the point that satisfies both of these equations. Right? So that's one way that we can do this. This is called the graphical method. This method is probably one of the worst ways to do it, mainly because you have to draw both the graphs, which is kind of a pain, but also because sometimes the points, like the point of intersection of the graphs, isn't directly on an integer interval. So it means meaning it could be like anywhere, like fractionally between 2 points, or between 2 whole number points. Okay, and so it might not be easy just to eyeball it. All right. Now in this case, I've worked out the equation beforehand, so I knew that this would meet in an integer with an integer solution. But it could easily be like a root 2 or something like that, and that would make it really difficult. Right. So this is not the best way to do it, but it is a way to do it. Right. So I just want to discuss one last thing here, and that is the number of solutions that we can have. Now, when we're talking about solutions and the number of solutions that we can have to a system of equations, what we're really talking about is the number of points where two lines can meet. Now, it's important to remember that the solution to the system of equations is the point of intersection between the two lines. Okay, so let me just write that down actually here. So, solution to the system of equations is the point of intersection between the two lines that are representing the two equations. Okay, so let's take a look at the possibilities here. All right, now one possibility, and I'll just draw this, is that let's say for instance we have one line. Okay, and it could be any line, it doesn't really matter where. Okay, so if I'm given just one line, there's an infinite number of solutions. Okay, however, with a system of equations, let's say for instance I have another line. Okay, so something like this. Okay, if I have a second line, okay, then I only there's some different situations where I can have. There's actually 3 different situations I can have. The first one is the one that you see right here. Okay, and that's where the lines meet only at one point. Okay, this always occurs when the lines are not parallel. Right, so let's just write this down here. Okay, so 1. If the lines are not parallel, then there will be only one solution to the system of linear equations. Okay. All right. Now that can be clearly seen. Okay, if I draw another line here. Okay, so if I draw a line like this, they're not parallel. It's only going to meet at one point. Okay, on this side they're getting further away. On the other side they're getting further away as well. So there's no way that the two lines can meet at any other point besides this point. Okay, another option is that the two lines are parallel. Right? Now, if they're parallel, it means that they can never meet. It means they're always the same distance apart, which means they're never going to come closer together, which means they will never have an intersection, and that means that they won't be able to have any solutions. Okay, so let me write that here. 2. If the lines, just a second here. Okay, so 2 is if the lines are parallel, then there are no solutions to the system of equations. I should be specific and say linear equations, actually. Okay, so there's no solutions to the system of linear equations. Alright, unless, okay, now here's the thing. If I were to draw a parallel line, you can see these two lines would never get together, and so they never meet, and hence there's no solution. However, there's one special case where there is. Okay, and that's what if I took this and I just dragged it over on top of it so that they represent the same line. Okay, now if they're the same line, that means that they meet at every single point, which means that there's actually an infinite number of solutions. Okay, so parallel lines never have solutions unless they are directly one on top of the other, which means that they are the same line. Okay, so let me just amend what I've just written there. Okay, so if the lines are parallel, then there are no solutions to a system of linear equations. Okay, unless they, well, let's just say so long as they are not the same line. And you can tell because they will not have the same y-intercept. Okay. We'll just move that in. Using the magic of technology, we will fit that all together here. Okay, now the last situation, which we just discussed, was what happens if they do have the same y-intercept, so meaning they are the same line. Okay, so 3. If the lines are parallel and they share the same y-intercept, then they are the same line and they have an infinite number of solutions. Okay, and that's really it. Those are the 3 different situations that you can get with solutions to linear systems of equations. Now, a common question that I usually get is, well, what if the line was not a straight line? Okay, so what if it was a bent line? Okay, and I'll show you an example here. Okay, so let's say, for instance, I had something like this. Okay, so I have a line and it goes like this. Okay, now in this case we'd have 2 solutions. Okay, however, the purple line is not linear. Okay, this is actually parabolic. Okay, so that means that this is not a system of linear equations. Right? So we're not going to cover this in this lesson, but there are ways to do it, and you can do it graphically as well, just like I showed you in this video, but we can also do it with equations, and I'm going to show you how to do that in the next 2 videos. Okay, so okay, if you do like the video, please give me a thumbs up. If you do like the channel, then please subscribe. And please stay tuned for my next 2 videos, which are going to be on solving these types of systems of equations using substitution and elimination.